Hello everyone, today we will explore three important aspects of WAN networking: point-to-point connection, branch connectivity, and access control lists, also called ACLs. These concepts are critical in understanding how networks communicate across distance, how organizations connect multiple offices, and how network security is enforced. Point-to-point connections are direct links between two connection endpoints, such as offices, data centers, or routers. These links are dedicated, meaning the bandwidth is reserved entirely for these 2 points, providing low latency and reliability communication. Examples include leased lines like T1 or T3 circuits, fiber optics connections, and even microwave links for long distance connections. They are often used in scenarios requiring secure or real-time communications, such as financial transactions or VoIP calls between offices. The advantages of point-to-point connections include very high reliability and low latency, which is essential for real-time services like voice or video communication. Since the connection is dedicated, it is also highly secure because no other users share the bandwidth. On the downside, these connections are expensive, especially for long distances, and are not scalable. If an organization has multiple offices, establishing separate point-to-point links for each office quickly becomes costly. Additionally, setting up physical circuits can take time. Branch connections are essential for organizations with multiple offices. They allow branches to communicate with headquarters and with each other. The most common technologies include MPLS, which is private, reliable, and guarantees bandwidth; VPNs over the public internet, which is use encryption to provide security at a lower cost; and SD-WAN, which is software-defined, flexible, and optimized for cloud applications. When selecting a method, organizations must consider factors like cost, performance, security, and compatibility with cloud services. Branch connections can be structured using different network topologies. The hub and spoke model directs all traffic from branch offices through a central hub, usually the headquarters. This is simpler to manage and secure, but if traffic is heavy, it can create bottlenecks. In contrast, a full mesh topology allows direct connections between branches, reducing latency and congestion. But it is more expensive and complex to maintain. Choosing the right topology depends on the organization's traffic patterns, budget, and need of redundancy. Access control lists, or ACLs, are a set of rules applied to routers, switches, or firewalls that determine whether network traffic is allowed or denied. Their purpose is to enhance security, control access to critical resources, and even manage traffic flow to reduce congestion. ACLs are one of the most basic but powerful tools in network security management. There are two main types of ACLs. Standard ACLs filter traffic based only on the source IP address. They are simple and useful for basic traffic control. Extended ACLs provide more granular control by filtering traffic based on source and destination IP addresses, protocols, or ports. This allows administrators to enforce detailed security policies. For example, you can block traffic from a suspicious IP, allow only HTTP traffic to a web server, or restrict SSH access to admin devices. Let's look at some real-world examples. Point-to-point connections are widely used in banking to securely link branch offices or between data centers to ensure fast, reliable data replication. Branch connections are common in retail chains, where stores connect to a central headquarters or in schools network connecting multiple campuses. SD-WAN is also increasingly used for cloud-based application. ACL are used to secure network by blocking suspicious IP addresses, allowing only authorized departments to access sensitive servers. or prioritizing traffic to VoIP servers to maintain call quality. Some best practices for these technologies for point-to-point connections monitor latency and uptime and implement redundancy for critical links. For branch connections, choose the topology based on traffic patterns and cost. Encrypt VPN traffic and monitor bandwidth to avoid congestion. For ACLs, keep rules well organized and documented. Apply the principle of least privilege by only allowing necessary traffic and regularly review rules to ensure security policies are up to date. To summarize, point-to-point connections provide secure, reliable links but are expensive. Branch connection links multiple offices with technologies like MPLs, VPNs, and SD-WAN. Using hub and spoke of full mesh topologies, ACL secure networks by controlling traffic. Real-world applications include banks, retail chains, school, and cloud services. Following best practices such as monitoring, encrypting, documenting rules, and applying the least privilege principle ensures these technologies work effectively and securely.